In this lesson, we will use the limit definition of the derivative to find the derivative step by step. Then we will demonstrate with a quick, clear example using f of x equals x squared. This formula captures the instantaneous rate of change at x, the slope of the tangent line to the curve at that point. Step 1. Define the function and compute f of x plus h. We will use the example f of x equals x squared. Then we substitute x plus h wherever we see x. So f of x plus h equals the quantity x plus h squared. Step 2. Compute the difference f of x plus h minus f of x. Start with the expressions and subtract. Now expand the square. The x squared terms cancel, leaving 2xh plus h squared. Step 3. Form the difference quotient. We divide by h. Now factor out h in the numerator. We can cancel the common factor h, giving 2x plus h. Step 4. Take the limit as h approaches 0. The derivative f prime of x equals the limit as h approaches 0 of 2x plus h. That is 2x plus 0, which equals 2x. This is the slope of the tangent to y equals x squared at x. Summary. Start with f of x and compute f of x plus h. Subtract to form f of x plus h minus f of x. Divide by h and simplify. Then take the limit as h approaches 0 to get the derivative. For our example, f of x equals x squared. The derivative is 2x. This completes our clear, step-by-step solution using the limit definition of the derivative. Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple, one video at a time, only on muyversemaths.